Hi guys, good evening everyone. How are you all? I hope everyone is doing well. Yes. How are you guys? Yes. How are you all everyone? Okay, good. So the topic that we are going to do today is again a very important topic, that is colligative properties. For sure you can expect one question from this topic, and this is going to be really interesting topic because here we'll be solving numericals, we'll be understanding theoretical concepts, so it's going to be really interesting topic. Yes, very good. So you all are going to enjoy it. So yes, good evening everyone. Okay, so for all of the new learners who wanted to know, yes, about your chemistry tutors, so I have the 5 years of experience for online and offline teaching. I have done my masters from NIT Warangal and bachelor's from Delhi University. I have cracked IIT JAM, NET, and yes, GATE. So I have cracked all these exams, as well as I have given very good ranks in NEET and JEE Mains through my students. And moreover, I am a plus verified tutor, guys. So yes, this is about me. Now tell me, I'll be telling you about a thing which many of the students, they ask me, that how we can get the class notes. Yes, how we can get the information regarding the class. So this you can get on our Telegram channel, guys. Yes, the link is there in front of you, even the scan code is there. So what you can do, you can just quickly scan it and you can be the part of our community. You can be the part of our Telegram group, and yes, there you'll be getting all the information about the classes, as well as you will be also, yes, getting all the notes, all the material which is required. Very good. So after that, let me tell you about a little bit our special classes. So the special classes which are there on the Unacademy platform itself, yes, what you have to know, what and all are the best things about it. The first thing is you can learn from your favorite educators for absolutely free. You can engage with educators via polls, which is not there on the YouTube classes. You can clear your doubts in the live special classes, and yes, what is there next? The special class timetable. So guys, this is the timetable which you can see. These are the topics which many of the students, they asked for. They wanted me to discuss the general organic chemistry before starting with the class 12 organic chemistry. Say they wanted me to revise these topics. So there is one class already I have taken, the special class for IUPAC nomenclature, right? If you will go to the Unacademy app and you will be checking, yes, you will be selecting your goal, which is ISC class 12, and then you will check the special classes. You will be able to see all the special classes which are already taken. So in that, yes, you will be able to see all the classes, and IUPAC nomenclature 1 part 1 is already done. Part 2 we'll be doing on 12th July 6:30 to 7:30 p.m. Then 14th July we'll be talking about inductive effect and resonance, and 19th July hyperconjugation and aromaticity, which is going to be really helpful for you for your class 12 organic chemistry, guys. So all of you must attend these sessions, because this is going to make you confident for the class 12 chemistry, like organic chemistry. It's very much required, because in class 11, know what happens, there are only 2 units, and which happens at the end of the, yes, which happens at the end of the class. And what you can relate, guys, yes, very simple, what we can relate. Just a second, guys, give me a minute. So sorry guys, there was some error, and because of that, like, I just checked it once. So really sorry for that. Yeah, so what I was telling about the special class timetable, so what you can relate is, yes, so IUPAC nomenclature part 2 will be there on 12th July, and then all these topics, they are going to really help you to, yes, have a really good understanding about the organic chemistry. So yes, that's what we understood. Now let me tell you what are the benefits of Unacademy subscription features. So first one, you can learn from the comfort of your home. Yes, you don't have to go anywhere, you don't have to waste the time to travel, to go, right? You don't have to waste that. So that time also you can invest for your studies. So very good. So what you can relate next, yeah. After that, what you have to, there is a unlimited access to all the courses, yes. And if once you have applied for the course, yes, what you can relate, you can have a unlimited. Hi Janni, how are you? So what you can relate, very simple, you have a unlimited access to all the courses. You will be learning from the top educators of India on one platform. You don't have to go at different places. You will be getting everything on the same platform, that is our Unacademy platform. And there are regular doubt clearing sessions, guys. If you will be taking the plus subscription, yes, the every fourth session is a doubt resolving session, guys. So you can resolve all of your doubt, how many ever you want, right? Obviously you can solve your doubts in the same session itself, but sometimes this happens, like we are solving many of the questions, and what happens, we are not able to solve like some particular type of questions, or like in sequence, like 3 questions, 5 questions, 10 questions. So that all that questions, what you can do, you can ask in the doubt resolving sessions together. And you can also ask to repeat some concept if you are facing difficulty in it. So that can be done, so it becomes like, which makes the things very easier. Now there is an exhaustive coverage of syllabus, guys. Like we complete the everything, like from scratch to advanced we go. And there is a throughout mentorship and guidance, guys, and you get all the study material in the PDF format, which is easy to access. You get the practice tests, and as well as there is a live test series, guys, which is the best thing, because how much ever you study the concept, until and unless you're not writing the test, you're not giving the exams, you won't get to know that how much, yes, you won't get to know that how much you have understood, correct? So this is what it is required, that you should write many of the live test series. By that you will be understanding that which and all concepts you are lagging and which and all concepts you have to work hard, yes. So that idea you can get. Very good, guys. Now talking about a very very important news, guys, that Unacademy plus subscription already is there at very affordable price, and you can use my code, which is MRIS10, anytime to get instant 10% discount. But the price hike is coming soon, guys. So the prices are really affordable, but it is going to increase a little bit. And yes, what you have to know, if you want to enroll for our plus course classes, now this is the time, this is the best time, because if you want enroll it today, right, what will happen, the prices are going to increase, and then you have to, like for the same quality education, you have to pay a little higher, so which is not required, right? So you can enroll for the session today itself, because the offer is going on from July 5th to July 8th. And in that, guys, yes, from July 5th to July 8th, the offer is going on. And what you will be getting in that offer, so first thing, you can use my code for that instant 10% discount, MRIS10. You will be getting that discount. But along with that, if you take a subscription for 12 months, you will be getting 1 month absolutely free. If you take for 18 months, 2 months you get free, 24 months, 3 months you get free, and 36 months you get 4 months, and 48 months you get 5 months absolutely free. Along with that, you also get a free Creative Corner extension. So that is also absolutely amazing, guys. So this is the time, because today is 7th and tomorrow is 8th. So this offer is going to expire even tomorrow. Yes. So what you have to do, and after that prices are going to increase. So what you have to do, if you want to enroll for our plus course classes, if you want to take the subscription, this is the time. Yes. Let me give you a little information about the upcoming batches which are going to be there from the 6th July. Yes, your one of the batch for class 12 has started, which is Achievers batch. In that, chemistry I am taking. Yes, physics is taken by Mohana Thara ma'am, maths is taken by Rahul Mohanani sir, and biology is taken by Lakshya Gera sir, guys. So we have, yes, all the schedule written over here. So all of you, what you have to do, guys, yes, you have to make sure that you are joining the sessions. Talking about the class 11, it also started from the 6th July, guys, and you have like I'm only taking the chemistry over there, and all the teachers which we have, like the same teachers here, even for all the subjects. So make sure, guys, you are enrolling for it. Yes, because if you will enroll for it, suppose if you're enrolling for ISC class 11, you will get ISC class 12 subscription absolutely free, and that too at very affordable prices. So you should not miss this chance, and you should go for it. Okay, so now without wasting a time, what we should will go to the next topic. So last time we discussed about the Raoult's law and a positive deviation and negative deviation from Raoult's law. That's what we did. Okay, now what we have to do, guys, we have to understand about a small topic which is azeotrops, and then we'll be talking about the next topic which is colligative properties. So what are azeotrops, guys? Yes, what are azeotrops? How you can define it? Yes, anyone knows what are azeotrops? Tell me, guys. Yes, anyone knows what are azeotrops? Yes, guys, tell me. Okay, so it's very simple, guys. Azeotrops, they are also known as azeotropic mixtures. Yes, azeotropic mixtures. They are also known as, guys, yes, azeotropic mixtures, and they are also known as what? The constant boiling liquids. So azeotropic mixture or constant boiling liquid, what are those? Let's just understand that. Yes. So this is the problem for the chair, guys, in which you can rotate. So sometimes you rotate and you go out of the frame, right? And when you're sitting on that chair also, you feel like what? Like you'll be feeling like, okay, let's just little bit move around. So this happens, right? So even like I'm going out of the frame some of the times. So yeah, so excuse me for that. So what you have is, like, we are talking about a topic which is a small topic but yet very important. What is that? Azeotropic mixture, and they are also called as constant boiling liquids. So talking about it, guys, yes, let's just understand what are azeotrops or azeotropic mixture or constant boiling liquids, how we can define it. So first thing that you have to know, yes, azeotrops, they are nothing but these are the binary mixtures. Yes, everyone, these are the binary mixtures. Binary mixtures means the one which has two components. So these are the binary mixtures. These are the binary mixtures having what, guys? Yes, having the same composition. So these are the binary mixtures having same composition in. Yes, having the same composition in. Yes, having the same composition in which phase, guys? In the liquid phase and vapor phase. So these are the binary mixtures having the same composition in what, guys? In liquid phase and vapor phase. Very simple. Phase and vapor phase. Clear with it, guys? Yes. So what you can relate is very simple, that what are azeotrops? Azeotrops are nothing but, yes, these are the binary mixtures having the same composition in liquid phase and vapor phase. Now if I'm telling, they are also known as constant boiling liquids, so we can also mention that and they boil at same, yes, and they boil at what? You can relate, guys, tell me. And they boil at same temperature, and they boil at what, guys? Same temperature, or they boil at constant temperature. Yes, that's what we can relate. So they boil at same temperature and constant temperature, are known as what, guys? Are known as azeotrops. So what you can relate, what are azeotrops? It's a small term, small topic, but still many of the people, they face difficulty to relate with it. So how you can remember? So azeotrops are the one which has the same composition in what, guys? Yes, in the liquid phase and vapor phase. So these are the one which has the same composition, liquid phase and vapor phase, and they boil at same temperature, guys, that is at constant temperature, and they are known as azeotrops. Very simple. Now what you have to know, that your azeotrops are also of two types. Yes, your azeotrops are of two types. Which and all? Azeotrops, they are of two types. So you can call it as minimum boiling azeotrops, or you can also call it as maximum boiling azeotrops. What is that? Minimum boiling azeotrops or maximum boiling azeotrops. Okay, now what you have to know in that case. So minimum boiling isotrops means you are getting from the name itself minimum and boiling. So boiling point is going to be less. By looking at this term itself, we can relate with it, yes. And maximum boiling isotrops. Obviously, the boiling point is going to be maximum, it is going to be more. Right? The moment you are learning the name, you are able to relate with it. So the one which is going to have a minimum boiling point, you can relate, no? The one which has a minimum boiling point, the one which has a less boiling point is going to have a high vapor pressure or less vapor pressure. Tell me everyone. The one which has a less boiling point, it is going to start vaporizing first, and the one which is going to start vaporizing first will have a more vapors, yes, and more vapors means more vapor pressure. So it's very simple. What you can relate here, that these are what? These are the substance which have it has, so minimum boiling isotrops are the one which has high vapor pressure. So it has high vapor pressure. So vapor pressure we write in short form as VP. So it is not vice president, guys, it is vapor pressure. Okay, and shows positive deviation because it has a high vapor pressure. So obviously it will be showing positive deviation to Raoult's law. So it shows positive deviation from Raoult's law. Okay, why? You can relate very simple because it has a high vapor pressure, and that is what you can relate. So it has a high vapor pressure and shows positive deviation from Raoult's law. Okay guys, I hope everyone clear. So if minimum boiling isotrops is this, so everyone can relate. Yes, what is going to be the maximum boiling isotrops? Yes, same definition, but what you will relate, instead of high it will become low, instead of positive it will become negative. Yes, everyone is thinking like that. If you are thinking like this, you are absolutely correct. So it has what you can relate. Yes, instead of high vapor pressure you will use low vapor pressure. So it has low vapor pressure and shows, instead of positive, the same definition you will write negative deviation from Raoult's law. So I made the definition so easier, no? It's just you have to change the terms and rest of the things are going to be absolutely same, and it's going to be easy. Okay, now talking about the examples for it. So you have to choose the examples which show the positive deviation and negative deviation. So for the minimum boiling isotrop, the example is ethanol plus, yes, ethanol plus water. Yeah, and what you can relate, the percentage that we take for it is 95% ethanol plus water. So if you will be thinking like this, guys, like the alcoholic beverages that like you see, that you must have heard about, right? Like if we talk about, you must have seen in the movies and all, they have like a very dilute versions of alcohol, like which is ethanol, like 5%, 8%, 20%, like that. But when you're talking about 95% of ethanol, it's a very concentrated. Yes, so if you take that, it is which one? It is a minimum boiling isotrop. Now talking about the maximum boiling isotrop, guys, what you can relate? Yes, you have, yes, what is maximum boiling isotrop? Example, you have HNO3 plus H2O. Yes, HNO3 plus H2O. And HNO3, what percentage you take? 68%, and H2 you take 32%, and this is what we can relate. I hope everyone is clear, guys. Yeah, tell me, everyone is clear that you can talk about all the examples which shows positive deviation, you can relate with the minimum boiling isotrop, and all the one which shows negative deviation, you can relate. Will be your the maximum boiling isotrops example. So this topic is done, and now let's just talk about the topic, the elephant in the room, which is colligative properties. This is one of the very, very important topic of the unit. Yes, that is solution. So let's just talk about it. So what is that? Yeah, the first thing we are talking about, what are colligative properties? Yes, what are colligative properties? So from the name, are you able to relate with anything? Yes, what are colligative properties? Tell me, guys, from the name, are you able to relate anything? So you don't have to relate it with Colgate or something, yes, because the name is looking like similar. You have to think, yeah, you have to think technically. So obviously the name is very different and new. So what you can relate, we'll be talking about it that what are colligative properties. So let me just define this first, and then we'll be understanding more about it. Yeah. So what is that? So colligative properties, yes guys, these are the properties which depends upon number of solute particles to the total number of particles. What you have to know, colligative property is a property which depends upon, yes, colligative property is a property, the properties which depends upon the total number of solute particles to the total number of particles present in solution. What you can relate guys, the properties, yeah, which depends on the properties which depends on the properties which depends on number of solute particles yes, to the total number of particles present in a solution, to the total number of particles present in a solution, yeah, and not on the nature of it. What do you have to know? Solution and not on the nature of it. So that is called as colligative properties. Yes. So how you can define it? The properties which depends upon what? The number of solute particles to what? Total number of particles. So basically it depends upon the concentration, that how many number of solute particles are there to the total number of particles, but it doesn't depend upon the nature of it. Like what is the nature, what are the forces of attraction, doesn't matter. It just depend upon how much number of solute particles are taking on the total number of particles. Clear with it guys? Very good. Now what you have to know next? The next is these are of 4 types. Colligative properties, what you have to know? These are of 4 types. Now what and all are there? Yes, tell me guys, what and all are there? These are of 4 types. The first one is relative lowering of vapor pressure. First one is relative lowering of vapor pressure. How you can write in short form? RLVP. Like as we give a short forms to everything, so that we don't have to write a big things. But make sure when you're writing in the exam, you're writing the complete thing guys. It's not like you write the short form, because many of the times the teachers which are there, right, they will not consider the short form. They'll write, you should write the full form, and that's actually required also, right? So make sure in your notes you can write the short form, but yes, in the exam what you have to do, you have to write full form of everything. So first one, the colligative properties, there are 4 types. Relative lowering of vapor pressure. Then you have the next thing is elevation in boiling point. Elevation in boiling point. Then next you have is depression in freezing point. Depression in freezing point. And last but not the least is the osmotic pressure. Is the osmotic pressure. Now if I tell you about one thing guys, very simple, we understood there are 4 types of colligative properties. Okay, now talking about the first one, which is relative lowering of vapor pressure, what we can relate about it, yeah, yes, or elevation in boiling point. How will be relating with all these properties? We have a common statement over here guys, right? So what you have to know, whenever you're talking about any of the first 3 properties, so you have to always remember, you will be always mentioning the common statement, like the common thing which you'll be considering over here, when a non-volatile solute is added to a volatile solvent. What you have to know guys, when a non-volatile solute, in all the cases we'll be doing this only, and then we'll be checking what happens to a vapor pressure, what happens to a boiling point, what happens to a freezing point, like that we get to know. So simple thing, that what you'll be doing, you'll be taking a non-volatile solute, the one which doesn't get evaporate easily, adding to the volatile solvent, the one which gets evaporated easily, right? And then you will check what happens, whether the vapor pressure, what happens to the vapor pressure, boiling point, freezing point, and what is osmotic pressure. So all these things we'll be learning here. Now, what is osmotic pressure? When a non-volatile solute is added to a volatile solvent, when a non-volatile solute is added to a volatile solvent. So this is a common statement for everything that you are going to study. Okay, yes, so you will be having a solvent which is volatile. Okay, what you are doing over here? Yeah, you are adding a, yes, a non-volatile solute. So sometimes like it's very easy, like when you want to interpret something, just make a small drawing for it. So for me, my drawing is not good at all, right? But whenever I have to understand anything, right, any point, I try to make a drawing. So a small drawing, a small illustration actually helps it. So even you guys can follow it, right? So what you will do, like you're just understood that non-volatile solute, you'll be adding to a volatile solvent, and then what happens, you see, right? So volatile solvent, then what happens? Yes, we see in 4 properties, that is RLVP, elevation and boiling point, depression, freezing point, and yes, elevation and boiling point. Can we give some symbol, guys? Yes, can you suggest any of it? Tell me, guys. Elevation in boiling point, EIVP. Depression, freezing point, DIFP. In short form, just like that we are writing according to the alphabeticals only, like very boring. We are just keeping the same, right? So that we can do. So osmotic pressure will be learning separately, but for the first 3, right, statement is going to be common, which we can relate. Okay, so let's just start with the first one, which is relative lowering of vapor pressure. Okay, let's just start with it. First one, relative lowering of vapor pressure. So what we can relate over here, guys? Tell me, everyone. Anyone is having any doubts till here? You can tell. Yes, everything is clear or not? Yeah, Janni, everyone. Everyone is clear. Anyone is having any doubt? Tell me, guys, quickly. Okay, let's just talk about relative lowering of vapor pressure. So what happens in that? So first thing, you will mention the same thing only when a non-volatile solute is added to a volatile solvent. Then what happens? Yes, so if you will mention the same thing, so what happens then? Vapor pressure decreases. So I'll mentioning here only once, and then you will relate with the other colligative property. So what I can write, when a non-volatile solute is added, to a volatile solvent, then what is seen, guys? Volatile solvent, then vapor pressure, then vapor pressure decreases. Very good. So what happened? Yes, this is what your relative lowering of vapor pressure says, guys. Now how we can relate with it, like how we can understand with it. So if suppose you have a solution, okay, you are having a solution in which you added a solvent and solute. Solvent is volatile and it is non-volatile. Now who will get vaporized, guys? Tell me. Solvent will get vaporized. If solute won't get vaporized, it will be having any vapors? Tell me, guys. So if it won't be having any vapors, so no vapors, no vapor pressure. Correct, you can relate. So can we use the Raoult's law, and we can write that here PA will be P naught A XA. Yes, for the solvent only, and PB will be equal to 0. Pressure required by the solute, it is going to be 0. Why? Because it is non-volatile. Can we relate with it? So PA is equal to P naught A XA, and this is for solvent. Can you relate with it, guys? Yes, this is for solvent. And for solute, it is going to be what? Yeah, for solute, because it is solute and it is non-volatile. Clear with it, everyone? This thing, everyone got it? Now we'll be driving a relation with the PA is equal to P naught A XA only. Very simple. So let's just do that. So we know that PA is equal to P naught A XA. According to Raoult's law, if anyone is having any doubt, you can go and check my Raoult's law video. You will get everything clear. So P is equal to P naught A XA. Now what you can relate, XA, can I write P naught A 1 minus XB? Can I do that, guys? Tell me. because you know XA plus XB is equal to 1. So you can write XB is equal to 1 minus XA. Yes, tell me everyone. So this is there. If I'll be doing that, if I open the bracket, I can write P naught A minus P naught A XB. Yes, I can do it. Now what I'll be doing, I'll be taking this side, that is P naught A XB is equal to P naught A minus PA divided by, like, what will happen? You have a P naught A XB. Correct. So what you can do, if you will keep the XB this side and you will, yes, take the P naught A to the opposite side. Here it is in the multiplication. So if it will go on the other side, what will happen? It will become in division. So XB will be equal to P naught A minus PA divided by P naught A. So this is the formula for the relative lowering of vapor pressure, guys. So if you get any time a question regarding a relative lowering of vapor pressure in which they are giving a same situation, so you have to use this formula, by which what you can do, you can find out the mole fraction of solute, and once you got the mole fraction of solute, you can find out the mole fraction of solvent also, because the formula is XA plus XB is equal to 1. So XB will be equal to 1 minus XA. Everyone clear? Yeah. Yes guys, I hope everyone is clear with it. Okay, now let me just tell you, if we have got this formula, what I can relate. So can you talk about the terms quickly? Yes, because many of the students know, they'll be like, we learned this in Raoult's law, what was the term, and like that you must be getting the questions. So what is this? P naught A is nothing but it is the vapor pressure of VP. VP is what? Vice President? Yeah? No, kidding. It's vapor pressure. Correct. So vapor pressure of pure component, it is P naught A. Correct guys. What is PA? Then PA is the partial vapor pressure of solvent. Partial vapor pressure. So VP of solvent A. Yes everyone, tell me. And yes, these and all are there in our formula. And what is XP guys? XP is the mole fraction of what guys? Mole fraction of solute, that is non-volatile. So what was the formula? I'm writing that again. So XB is equal to P naught A minus PA divided by P naught A. Remember this formula guys, you'll be getting many of the questions related to it. Yes, very good. So this was about your relative lowering of vapor pressure that we can relate. So what you can understand over here guys, we can just little bit talk about the graph also here, that what happens. Suppose if we are plotting a graph between vapor pressure and, yes, if we are plotting a graph between vapor pressure and temperature, what we can understand here guys, tell me. Yeah, we can understand a very simple thing. Suppose you are having a solvent, okay, which was having some vapor pressure, which you can relate. But when you made the solution, yes, when you made the solution, so what you can relate, before, if the boiling point was this was the TB, right? Now what is happening? The boiling point for this is, okay, we can make the graph little more clear because I have drawn the line from here, so it will be little confusing. Yes, so see, you have a solvent, okay, so at any particular pressure, say at 1 atm, if you will check, 1 second. So we have the graph which we are plotting between vapor pressure and temperature. Okay, now what you have to do, that for solvent, obviously you know what is the vapor pressure, okay, you have find it out. Now at a particular pressure, that is say 1 atm, okay, let's just say you are doing at 1 atm. So what you will do, like at 1 atm pressure, like what you will be checking, that what is the vapor pressure of solvent and then what is the vapor pressure of solution. Okay, so solvent is this, and if I talk about solution, this is my solution. Okay, that's what we can relate. Now what you have to know, that for solvent, yeah, can you relate with it? For the solvent, can I tell what will be my boiling point? Yeah, because obviously this is going to be my boiling point for solvent, but for solution it is going to be what? It is going to be this. This is say my TB. Yes, this is for the solvent, so I can write TB naught, and this can be for my solution. Correct. And you can find it out for the whole. So you can know that for solvent the boiling point is less. So you know now boiling point and how it is related with the vapor pressure. It is inversely proportional to vapor pressure. Yes. So what you can relate is that the boiling point for the solution increases, and because of that you can relate vapor pressure decreases. As simple as that. From this graph even we understood about the elevation boiling point also. No, what you can relate. Yes, when you added a non-volatile solute to a volatile solvent, what happened, guys? Very simple. The boiling point increased, and the boiling point increased. Yes, you can relate this is for the solvent and this is for the solution. And if you can relate this for the solution, will you be able to find out the delta TB? It means change in the boiling point. You can find that. Very simple. Yeah, everyone, tell me. Very good. So what you can relate is that from this only we can go and learn about a next property, which is elevation in boiling point. Can we learn about it, guys? Yes. So our next, the second property, that is elevation in boiling point. Now we'll be doing some questions also related to it. So elevation in boiling point. Let's just discuss these two properties and then we'll discuss some questions related to both. What say, guys? Yeah. So elevation in boiling point. So elevation in boiling point, what we can relate? Yes. How we write it? Very simple. Can I write that statement again? Okay, let's just write it for those who have just now joined it. So what is the common statement for all the three colligative properties? Very simple. When a non-volatile solute is added to a volatile solvent, yes, is added to a volatile solvent, what happens, guys? Now am I going to write vapor pressure? If you want you can write, but not required. So you can write when a non-volatile solute is added to a volatile solvent, then its boiling point increases. So tell me, guys, with how many of you this happens? Yeah, that like suppose if there is a solvent, like because this happens with me very like quite often. So here, like when you have to write solvent and then like you have to write both T will come, so you skip one of the alphabet in that, like solvent then. So what I'll do, I'll skip one of the T in that. So this happens when you write in the flow, right? So when a non-volatile solute is added to a volatile solvent, then its boiling point, yes, increases. Then its boiling point increases. Correct, guys? We can write it. Now we can find it out what is the change in boiling point. So change in boiling point will be very simple. The TB, yes, TB we can relate, and TB not. So TB is the boiling point of, TB is the boiling point of solvent and TB not is the boiling point of solution. Tell me, guys, yes, TB is the boiling point of solution and TB not is the boiling point of solvent. Boiling I have written, I skipped the point as well, yes. So what is that, guys? Boiling point of solution, and then next is boiling point of what, guys? So I guess I'm feeling hungry, I'm eating some words because of that. Yeah, so boiling point of what? Solvent. What say, guys? Very simple. So delta TB is equal to TB minus TB naught. Then what it gave? It gave us a relation after a lot of experimental studies, after a lot of results, conclusions. What we got? That a change in boiling point is directly proportional to molality. What is small m? I hope everyone is able to relate molality. Yes. What is that that you can relate? That change in boiling point. Yes. Change in boiling point is directly proportional to what, guys? Yes, is directly proportional to molality. Okay, so you must be knowing that whenever there is a proportionality sign, yes, whenever there is a proportionality sign, you have to remove it so that you can do some calculations from it. If you have a proportionality sign, you cannot do the calculations, right? So you will be removing it and you will get a constant, which is KB. Now what is KB, right? So if you will put after KB a C, it will be kaun banega crorepati, is it? So it was not a good joke, but yeah, like what is KB? How you can define it? Yes, KB is a molar elevation constant. what it is molar elevation constant. Is there any other name for it also, guys? So other name, when you will hear, you will be like crying, what, this much difficult? So molar elevation constant, it is also called as ebullioscopic constant. What is that? Ebullioscopic constant. So very simple, guys. Kb is a molar elevation constant or ebullioscopic. E for elevation, E for ebullioscopic, like that you can remember, right? Very good. So this we have got the formula. Now you must be thinking that how we get this Kb. So this value we get, Kb we get experimentally only. Kb value, how we get it? We get it experimentally only. And how we get? With the help of experiment and one formula. And what is that formula? R into Ma into T naught B square, which is obviously for solvent, boiling point of solvent divided by 1000 into enthalpy of vaporization. Everyone is able to relate with it, guys? Tell me. So R is what? R is a universal gas constant. What is Ma, guys? Yes, Ma is the molar mass of solvent. So this formula, generally you don't get a question from this formula, but this is just for the information that how you get the Kb. Okay. So universal gas constant, M is the molar mass, and of what? Of solvent. Correct, guys? Then you have Tb naught. What is that? Can anyone tell? Yeah, it is very simple. The molar, no, it is a boiling point of what? Boiling point of solvent. Okay, boiling point of solvent. Then you have 1000. What is 1000, guys? 1000 is a number. It's 1000. Correct. Very good. Then delta H vaporization. What is enthalpy of vaporization? Enthalpy of vaporization is enthalpy of vaporization. Change in enthalpy that occurs when 1 mole of what? Liquid gets vaporized to gaseous state, obviously. So enthalpy of vaporization. These in all terms you can find out the Kb value. Can I do some modifications in the delta Tb value? What say? So delta Tb is equal to Kb. Now what is molality? Everyone remember? So if you don't remember what is molality, see my lesson for, see my session for concentration terms. It is there in two parts, part 1 and part 2. So in part 2 you can see what is molality. So molality is given mass divided by molar mass into 1000 divided by, yes, divided by, tell me, mass of solutes, not solute, mass of solvent in what, guys? In grams. So this I have little bit elaborated, which is going to help, yes, which is going to help you to solve the questions related to it. Yes, everyone? Very good. Okay, correct. So what you can relate is that, very simple. Yeah, what you can relate, this formula is going to be useful for us whenever we have to do the questions related to it. So let's just do 1-2 questions which are like a very famous type of questions from this. Yes, let's just do that. What say, guys? From the relative lowering of vapor pressure and elevation in boiling point, let's just do it. Okay, so let's just do that. So first question which we'll be doing regarding the what is that? Relative lowering of vapor pressure. So but before that I want to ask everyone, guys, anyone is having any doubt, you should ask. Yes, everyone, tell me, anyone, any doubt? Yes, guys, till here anyone, any doubt? Okay, no. So okay, good. Let's just do one question. Yes, which is a good question. Okay, which is a question even in the NCERT as well. So but it's going to give you a total idea that how you can use the relative lowering of vapor pressure. So the question is, the vapor, yeah, the vapor pressure of pure benzene. So I'm writing the question. Till that time you can just note down the formula quickly, right? So the vapor pressure of pure benzene, yes, at a certain temperature. At a certain temperature is, yes, 0.850 bar. A non-volatile solute right, a non-volatile solute weighing 0.5 gram, when added to 39 gram of benzene, yes, what it says, vapor pressure of the solution then is, yes, vapor pressure of the solution then is 0.845 bar. What is the molar mass of solute? See, you will understand a very good thing about from this question. What is the molar mass of the solute? So first I'll be giving 1 minute time to everyone. Suppose we have done 2 colligative properties. So you have to read the question and try to figure out. Hi Ayush, how are you? So Ayush, try to do this question. Yes, we are here right now. So let's just do one question related to your colligative property. So you have to quickly read the question and tell me from which colligative property it is going to be. Let's just see whether you are able to figure it out or not. Yeah. So the question, what it says, yes, it says that the vapor pressure of pure benzene at a certain temperature is 0.85 bar, 850 bar, a non-volatile solute you have added whose mass is given. When added to 39 gram of benzene, then vapor pressure of the solution will be how much? What is the molar mass of solute? Correct? So that's what they are asking. Let's just see what we can do here. Okay. So very simple. What you can relate here is a small thing, that what and all things are given to you. First, they have given the P naught A, which is for the benzene, and how much it is given, guys? 0.85 bar. This green color is visible to all of you, right? Okay, very good. So P naught A is equal to 0.85 bar, 8, like what they have given, 5 bar they have given, and what they have given, yes, a non-volatile solute is added, vapor pressure of solution is 0.845, right? So you can relate that, because for the solution, yes, the vapor pressure decreases, so it is going to be 0.845 bar. So decreasing only. Very good. Now for the benzene, Ma, you know the mass, which is C6H6. Can you calculate, everyone? Tell me. Oh, it's going to be so damn simple. 12 plus 6, 12 into 6 plus 1 into 6. You will get 78 gram per mole. So you got the molar mass for here, 78. And what they're asking you to calculate the molar mass of what? B, that's the solute. But before that, let's just write some information about the solute also, no? That they have given Ma is 78, because they said what it is, it's benzene. Then what they have given you the WB, which you are taking 0.5 gram, and WA also they have given, which you are taking 39 gram. Are you able to relate with it, guys? Yes. Let me just show you the question. Check. Are you able to relate with it? These and all things do you have written about the question? Yes. Very good. So if you have understood that WB is equal to this, W is equal to this, what you have to know, everything is given to you except, yeah, except the molar mass of solute. So can we find it out, guys? Yes. Can we find out MB? So everything is given over here. All this thing is given. And you have to find out MB. So think about the formula. XB is equal to, yes, P naught A minus PA divided by P naught A. Now what you have to know, guys, PA you can relate is equal to PS. Why? Because you know that PA plus PB is equal to 0. Like PA is equal to PB is equal to PS. And PB is 0. So PA becomes equal to PS. Simple. Yeah. So can you use this formula? Tell me, guys. It's easy, no? So XB, how you calculate the mole fraction of solute, number of moles of solute divided by number of moles of solvent divided by plus solute is equal to P naught A, like everything is given to you. P naught A minus PS, I can write instead of PA. Yeah, everyone, can you relate with it? Yes. So what do you have to know? The number of moles, how you calculate given mass divided by molar mass. Here given mass divided by molar mass plus, yes, the given mass divided by molar mass. Now here you must be thinking, it's going to be really difficult because you have to down also you don't have this thing, here also you don't have this thing. So remember here guys, you can neglect the molar mass of moles of solute in comparison to, yes, in comparison to solvent, because solute is always taken in very less quantity. Now, so if you will neglect it, you'll be left with what? This, and value you can put P naught A, everything is given to you. P naught A is what? 0.85 minus 0.845 divided by, yes, your 0.85 only, 850, okay. And WB is given to you. WB is given to you how much? Yeah, tell me. WB is given to you 0.5 divided by, you can relate MB. So this you can write, no, 0.5 divided by MB, you have to find it out, and this you will neglect. So WA is given to you, what is that? Yeah, 39 divided by 78. So you just solve it, you will get the answer easily. Yes, I hope everyone is able to relate with it. So you will solve it and you will get them too. Clear? So solve it guys, and if you feel any doubt is there, just let me know in the next class. Okay, we'll be discussing more of the questions related to qualitative properties. That's why our next class, which is there, today is Thursday. So we'll be having on the, yes guys, we'll be having this on the Monday, and Monday we'll be having the class Qualitative Properties Part 2. Yes, in that we'll be doing some questions related to it, as well as the properties that we have already done, as well as the remaining 2 properties also we are going to do. Okay, very good guys. So this is what we have done, and what we have done today, let me just quickly summarize it, and then we'll be talking about more of the things. So first thing, we started with the azeotrops. What are the azeotrops guys? These are the binary mixtures, right? Binary mixtures means what? The one which is made up of 2 components. Very good. So these are the binary mixtures which have the same composition in liquid phase and in vapor phase. Same composition, it doesn't change. Okay, and they are also known as constant boiling liquid. So they obviously boils at constant, yes, temperature. And what do you have to know about azeotrops? That you cannot separate it from fractional distillation. It's not so easy to separate them. And one more thing which we can relate about azeotrops, that they are of 2 types. Again, we are getting so many 2s, no? Yeah, so they are of 2 types again. What is that? Minimum boiling azeotrops, maximum boiling azeotrops. Minimum boiling azeotrop, we can relate, minimum means minimum boiling, right? Minimum boiling point means high vapor. So if high vapor means positive deviation from Raoult's law, very simple. So the one which shows a positive deviation from Raoult's law, as well as they have a high vapor pressure, example we can learn, and opposite goes for the, yes, maximum boiling azeotrops that we have learned. Now what you have to know next, yes, other than that, we talked about the colligative properties, the properties which depends upon the number of solute particles to the total number of particles, and not on the nature of it. And there are 4 types, yes, which and all, can everyone count it? Now this is 4 after 2, a long number, right? So relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Now for the 3 we have discussed that we are going to use the same statement, that when a non-volatile solute is added to a volatile solvent, correct, what happens? The vapor pressure decreases, boiling point increases, freezing point decreases. So one by one we'll be learning that. So we learned about relative lowering of vapor pressure, how it decreases, right? What is the expression that we can use, and so on. And same for the elevation in boiling point also we understood. Okay, very good. So this is what we have done. Now let me tell you about a very, very important information guys, that our Unacademy prices, they are at very affordable price, but the price hike is coming soon because of the demand and because of the everything. So obviously the price were low from the long time, so it's going to be increasing. And what you have to know guys, yes, it's very important that the quality education you're getting at affordable price, and if the price is going to increase, obviously you have to pay more. That's not going to be worth. So if you want to enroll for our plus course classes where we do the complete course and everything, and you have a complete mentorship, what you have to do, make sure you are enrolling between July 5th to 8th. Now the problem is today is already July 7th, so July 7th and 8th you have only 2 days, guys. So these 2 days, what you have to do, yes, you have to make sure today, if not today, tomorrow for sure enroll for our plus course classes. Yes, and for the subscription you can use my code, which is MRIS10. You will get instant 10% discount. Now what offer is going on? So you will get instant 10% discount. There is no price hike, the normal price is only, and along with the 12 months you will get 1 month free, with 18 months 2 months free, you will get with 24 months, you will get 3 months, with 36 months 4 months, and 48 months 5 months. Isn't it amazing? Yes, you will be getting a good offer, very good. So make sure you are enrolling, yes, today itself, right? Because you must have heard that doha, no, kaal kare so aaj kare so ab, right? So if you want to enroll, you should enroll, and you should enroll it today itself, and use my code, which is MRIS10. You will get instant 10% discount. Now let me give you the information about our batches. So there is a Achievers batch which started from the July 6th, and it's all subjects batch. In that, chemistry I am taking on Monday, Wednesday, Friday 4 to 5. Physics is taken by Mohana Tharam ma'am, maths is taken by Rahul sir, and biology is taken by Lakshya Gera sir. Yes, so we all four are going to cover each and every topic in all the subjects. So you have to make sure you're enrolling for it. And if if your sibling is there in 11th standard, if your any friend is there in 11th standard, you can suggest them also to take the course, right? Because they'll be getting a benefit. If they enroll for class 11, they'll be getting even class 12 subscription absolutely free. Yes, so the same teachers are here which will be taking the classes, and the time schedule is given on the screen. Yes, so let me introduce you about the community, guys. So our community is really fab. Yes, why? Because here you will be getting every update from your favorite teacher instantly. You get the session notes, practice material. You can share your feedback directly with the educators via polls, and you are in 24 hours connect with your teacher, right? So this is what we have done today, and I have given you a very important information too. So I hope you all will be enrolling for our plus course classes, and you will be revising the topic also what we have done in today's session. Okay. So, okay guys, we'll be meeting in the next session then. Thank you all of you. Bye all the lovely people. Thank you guys. Bye everyone.